6.4 Partial fractions. Find the partial fraction decomposition of this fraction. In other words, turn this fraction into two fractions that are equivalent. Let's factor the denominator. We have x minus 4 times x plus 3. We want to turn x minus 25 over x squared minus x minus 12 into a over x minus 4 and then plus b over x plus 3. Now let's get common denominator. Let's multiply this one by x plus 3 over x plus 3, and we'll multiply this one by x minus 4 over x minus 4. Well, now that we have all common denominators, we can write x minus 25 is equal to a times x plus 3 and then plus b times x minus 4. X equal negative 3. That makes this piece 0 right here. And then we'll have negative 28 is equal to, if we plug negative 3 in over here, we have negative 7b. So b now is equal to 4. Let's now let x equal 4. That makes the other one 0. And we'll have 4 minus 25, that's negative 21, is equal to 7a. Now a is equal to negative 3. So the two fractions that we're looking for now is negative 3 over x minus 4 and then plus 4 over x plus 3. Find the partial fraction decomposition of this one when the powers are exactly the same on the top and the bottom, or if the one on the top is bigger, then we have to do long division. Well, we're going to have to do long division with this one because the powers are the same. So we're going to divide x squared minus x into negative 2x squared plus 9x minus 4. X squared goes into negative 2x squared negative 2 times. We have negative 2x squared and then plus 2x. And in long division, we always subtract. We have 7x minus 4. Now we have negative 2 and then plus 7x minus 4 over x squared minus x. Let's factor the denominator. We can take an x out. We get x times x minus 1. And we should be able to write 7x minus 4 over x times x minus 1 as a over x and then plus b over x minus 1. Let's get common denominators. We need to multiply this one by x minus 1 over x minus 1 and this one by x. Now 7x minus 4 has to equal a times x minus 1 and then plus bx. Let's let x equal 1. That way we have 3 is equal to 1 times b is b, so now we know b is 3. And if we let x equal 0, we should be able to find out what a is. We have negative 4 when we plug in 0 on the left, and that's equal to negative a. A is equal to 4. So now we can write the original as negative 2 plus 4 over, let's see, a was over x, so 4 over x and then plus 3 over x minus 1. Find the partial fraction decomposition of this one. Again, the powers are tied, so we're going to have to do some long division. We're going to divide that polynomial into 3x squared plus 7x. X squared goes into 3x squared 3 times. We have 3x squared plus 21x plus 36. And then when we subtract, we get negative 14x minus 36. We can write the original as 3 plus negative 14x minus 36 over x squared plus 7x plus 12. Let's factor the denominator. We have x plus 3, x plus 4. And we should be able to write negative 14x minus 36 over x squared plus 7x plus 12 as a over x plus 3 plus b over x plus 4. Let's get common denominators. We have x plus 4 over x plus 4. And on this one, we need to multiply by x plus 3. Now we have negative 14x minus 36 is equal to a times x plus 4 plus b times x plus 3. Let's let x equal negative 4. We have 56 minus 36 is equal to, this part will be 0, and then we have plus, actually minus 4b. So we have negative 4b, and then we have 20 is equal to negative 4b, so b is equal to negative 5. Let's, we can do this down here. Let x equal negative 3. We have 42 minus 36 is equal to a. So a is equal to 6. Well, now the answer is 3 plus, let's see, the a is 6, so we have 6 over x plus 3. The b is negative 5, so we have minus 5 over x plus 4. The a is over the x plus 3, and the b is over the x plus 4. Find the partial fraction decomposition of each improper rational expression. Well, now the power on top is bigger than the power on the bottom, so we will have to do long division here. We have x squared minus 2x, and we're dividing that into all of the numerator, which is x to the 4th minus 2x to the 3rd minus 2x squared plus 8x, and then minus 6. X squared goes into x to the 4th x squared times. That way we have x to the 4th minus 2x to the 3rd. And when we subtract, both of these go away. So let's bring down negative 2x squared plus 8x. X squared goes into negative 2x squared negative 2 times. We have negative 2x squared and then plus 4x. Let's subtract. We have 4x minus 6. Well, now we can write the original as x squared minus 2 and then plus 4x minus 6 over the denominator. And if we factor this denominator, we get x times x minus 2. We can write 4x minus 6 over x times x minus 2 as a over x and then plus b over x minus 2. Let's get common denominators. We can multiply this one by x minus 2 over x minus 2 and multiply the right one by x. 4x minus 6 is equal to a times x minus 2 plus bx. We'll let x equal 2. 8 minus 6 is 2. This will be 0, and then we have 2b. b is equal to 1. Let's let x equal 0. We will have negative 6 is equal to negative 2a. A is equal to 3. Let's go back to right after we divided to this spot right here, and we have the x squared minus 2. So we have x squared minus 2, and then we turn this fraction into these partial fractions. So that'll be plus, the a is 3 over x, and then plus 1 over x minus 2. And there's your answer. Find the partial fraction decomposition of each rational expression with repeated factors in the denominator. Well, the top power is smaller than the bigger power, so we don't have to divide here. We can factor the denominator by taking an x out, and we have x squared plus 8x plus 16. And this factors into x plus 4 and x plus 4. We can write this as a over x plus b over x plus 4. And here's the tricky part. Now we write plus c over x plus 4 squared. And then if there was another x plus 4, we'd have it to the first power, to the second power, and then we'd write another one to the third power. Well, let's get the common denominator on this one. This one needs an x plus 4 squared. This one needs an x and an x plus 4. And this one just needs an x, on top and bottom, of course. Well, now we have negative 5x squared minus 6x plus 16 is equal to a times x plus 4 squared plus bx times x plus 4, and then plus cx. In this one, we have to multiply everything out on the right side. We have a times x squared plus 8x plus 16, and then plus bx squared plus 4bx, and then plus cx. Let's distribute the a. We have ax squared plus 8ax, and then plus 16a, plus bx squared plus 4bx, and then plus cx. Let's look at the coefficients of each of the terms here. The coefficient of x squared is negative 5, so on the left side we have negative 5, and the coefficients on the right side we have a here, and then plus b. So negative 5 better equal a plus b. Let's look at the coefficients of x. On the left side we have negative 6, and then on the right side one of them is 8a, so we have 8a. Another one is 4b, so plus 4b, and another coefficient of x is c, so plus c. Those better be equal to each other. And then let's look at the constants, so the ones without x. 16 is on the left side, and then on the right side the only thing we have is 16a. So 16 better equal 16a, so a better be 1. Well, now that we know a is 1, we can plug 1 up here and find out what b is. Negative 5 equals 1 plus b. b now is equal to negative 6. Well, now if we know a and b, we can find c. Negative 6 is equal to 8 times a, which is 8, 4 times b, which is negative 24, and then we have plus c. Negative 6 is equal to, that's going to be negative 16 plus c, and then when we add negative 16 we get 10, so c is 10. Now we can write this as 1 over x, the a is 1, the b is negative 6, we have minus 6 over x plus 4, and then the c is 10. We have plus 10 over x plus 4 squared.